This is the first video for Unit 2, Waves and Sound. The first thing we're going to talk about is pendulums and simple harmonic motion. A pendulum is a massive object suspended by a string or a light rod. And when they say massive, they don't mean like, it doesn't necessarily need to be super large, but the mass of this ball is greater, much greater actually, than the mass of the string. And so that allows us to not have to worry about counting the mass of the string, and it's relatively weightless for our calculations. We're going to introduce a couple of forces. We'll talk about these forces more when we get into forces, but the tension force is basically the force on your pendulum, whatever it is, a ball hanging from a string, that force that keeps the string and whatever your object is, in this case it's a ball, connected. And then you always have the gravitational force going down. And by the time you get to the second semester, we will talk so much about G that you will be like completely tired of G. And then the net force is just that even force, or the total force acting on this ball. And you can see the net force is going that way, and that's why the ball has this motion, kind of like this. It's a little neater than what I've drawn, but it basically has this motion like this because the net force when you're over here is there, and when you're at the right side, it's over here, and it's just smaller and smaller and smaller and smaller and smaller and smaller until your tension force and your gravity force are equal to each other because they're both vertical. Periodic motion, this is just something that's repetitive. You guys know the periodic table from chemistry, okay? And the reason that it was named the periodic table is because those elements had repetitive properties. Every eighth element, the properties repeated, and so they called it the periodic table. And so this is any motion that repeats on a regular cycle. That pendulum motion that we talked about before, that is periodic motion because it's going back and forth and back and forth. If you have a slinky and you drop it, we'll do this in class, it'll kind of bounce, and then it'll bounce up, and then it'll bounce down, and it'll bounce up, and it'll bounce down, until it sits at that rest position. And that's also periodic motion because it's going back and forth. And then simple harmonic motion is that specific type of periodic motion that you would have with a pendulum or a spring. So some terms we need for simple harmonic motion. The period is the time to complete one complete cycle. So if you've that pendulum here, and it's going here, and then all the way back to its start position, that would be the period, the time it takes for it to do that. The amplitude is the maximum distance that it moves from equilibrium. Equilibrium in our pendulum is right here, so this maximum distance would be the amplitude. In a slinky or a wave, the maximum distance, if you have a slinky like this and you have a weight on it and it's pulled all the way down like this, but its rest position is right here. This distance between the rest, when it's all the way at the top, or all the way at the bottom, is the amplitude. And with a slinky, you'll notice, you pull it down and it goes back up, and then it comes down a little bit and goes up, and it comes down a little bit, and your amplitude will kind of change.